Hi everyone, welcome back to the third part of SAM version 2 segment anything model version 2. And in this video, we will learn how to segment the video. So basically, we'll try to segment the objects that are present in the video. And first of all, I'm very sorry for uploading this video so late, but here I am, and let's get started and dive into the code. So, in previous two videos, we basically started with downloading the checkpoints. Checkpoints are nothing but the model weights, and we have like four model weights available to us, as in tiny, small, base plus, and large. Proceeding forward, we just created the CUDA environments. We created the checkpoints folder. We basically took one sample image of the dog and we tried to segment using the image. Next, we tried prompting with the boxes. So we basically bounded the objects with the boxes to segment them. And following in this video, we will try. Okay, here is the segmenting with the bounding boxes, and that's how it will look in the results, like it is highlighting here with the different colors each and every object. So now we'll basically proceed with the video segmentation. So starting from the imports, I'm importing OpenCV2, Torch, Base64, NumPy, supervision for multiple utilities for video segmentation, the pathlib for creating the paths, and next is like download assets for downloading the sample video from the supervision library, the video assets again for the same purpose. Now we are using the built SAM2 video predictor. So earlier we were using the image predictor. Now we are using the video predictor because now we will be segmenting the objects inside the video. So how the workflow looks like, basically I have a video, uh, and from that particular video I'll basically take out all the frames are nothing but the images, so video is nothing but the sequence of images, right? So I'll just take all the frames from the video, save them into a folder, and we'll basically select a particular object using the bounding boxes. We'll draw the box around that particular object in the image, in any one of the image, and that particular object will get segmented in all the frames, all the saved frames. And in the end, what we'll do, we'll basically merge all those frames into a video again, so that you can see the highlighted object in a continuous video that is made up using the frames which have the segments defined inside them. So let's proceed. So here I am again setting up the CUDA like we did earlier in first two videos. If you need some explanation, then you can follow up in the first or the second video. Next, I'm taking the config, and I'm taking the checkpoints of the large model. Next, I'm creating the SAM2 model out of the video predictor, providing the config and the checkpoint. Now, like I have imported video assets from the supervision library in here, right? So if I do the directory of video assets, it shows me multiple options over here. These are nothing but the sample videos that are present within the library. And for now, I'll be taking the subway video. So how it looks like, I'll quickly show you. So okay, I have downloaded the video already, and this particular utility is nothing but we are defining the scaling factor, start and end indexes, and the source frames are nothing but the path, the home path, and the source video path. So this will be basically the video that we are storing. So I think it should be somewhere here. So we have the subway.mp4, and this is the source video path. Then we are creating a frame generator using supervision get video frames generator. We are providing the source video path, the start and end index. Now we are creating the image sync using again supervision image sync, providing the target directory path. So that is nothing but the source frames will be stored in that particular path. So I have created a separate folder as subway, where I'll basically store all the frames from the video. overwrite is true. So let's say if I'm doing it again and again, so it will overwrite those frames instead of just appending or maybe like adding on the frames to the current folder with the past ones. So it will just overwrite the frames. Then the pattern. So this is nothing but the JPEG file. So let's proceed with the loop. So with image sync, it will proceed with the frames one by one from the frames generator and try to basically perform the scaling of the image and on the particular selected frame with the scale factor. So scale factor we have defined over here, and it will save the image. Basically, it will save the frame into this particular folder. So once I run this, I'll be getting the frames inside this folder as like we'll have these as numbered from 0th index and so on. So it will depend on the number of frames your videos or the video is having. Next, we will see the inference state. So it is nothing but the model that we have built, SAM2 model, right? Using the video predictor. We are initializing the state with the video path. That is nothing but the source frames, again, this particular folder. And then we are doing the reset state with the inference state that we have just defined above here. Now we are defining a utility function over here, that is encode image, and we are providing the file path. So this particular file will be opened and it will be the base 64 encoding will be performed on that particular image for the processing, further processing. Now, for example, I just want to keep two objects that I want to segment within my video, that is person 1 and person 2. So I'll just take the frame index as 0 and the frame path I'll provide with the very first image, just for basically providing the bounding boxes in one of the image, so that my video predictor knows what object to segment within, right, within the all the video frames. So I'm using widget for visualization purpose and plotting the boxes around the object. So when I do this, I will get this image, and over here you see I have defined two classes like above, person 1 and person 2. So I can highlight those. Either I can just click and select the person, or I can maybe draw the bounding boxes like this. So let's say this is person 1, and similarly I'll go to person 2. So let's say my person 2 is this. All right, not a perfect one, but yeah, let's see how it works. And let's do the submit. Now we have some default boxes defined for X, Y, width, height, and the label. So over here I'll just give it as person 1, and here I'll give it as person 2. Now we'll just proceed running this cell. So what exactly it is doing, it is taking the boxes and it is running through all the objects, and it is running the enumerations, object ID index wise, as well as the labels. So label is nothing but the person 1 and person 2 over here. So it is taking the boxes for each and every label, and then it is basically creating it as a numpy array for with the x and y axis for both the boxes, and labels is nothing but the length of the points. Now the SAM2 model, what it is doing, it is just performing the add new points and providing the inference state that we have defined in the above cell, and providing the frame index, object id and along with the points and the labels. So once we run it, let's proceed. All right, then a final thing that we have to do is we'll basically save all those what do you call it, the video frames as a single file into a particular format that will be the video format, and our new segmented video will be ready to use. So let's say if I open any one of the images, let's say the serial image. All right, so here is your image. So this image and following with each and every image in the sequence will be added and a video will be created out of it. So let's run through it. So we have like mask annotators, and we have the video sync defined with the target video, and again, like it is looping through the video, like it is using propagating video, and the inference state is again provided, and frame by frame, like frame by frame, it is taking out the objects and it is masking them. So what is happening, we are creating the bounding boxes around the objects like person 1 and person 2. So it will be creating the mask for those particular objects within each and every frame, and this loop will be running throughout each and every frame. And you see that detections is also being used from the supervised library, and it is performing, it is detecting the particular objects and creating the mask. Now it is doing annotations over here using mask annotator dot annotate, and it is writing into the frame. So once we do this, let's run it. All right, it will take some time. All right, so it has finished. Now let's quickly see the grid. All right. So we highlighted two-person over here, but I can see just one being segmented. I'm not sure why it did not work well. Maybe let's do it one more time. All right. Let's run the frame again. Okay. So this is the person I'm highlighting, and this is the next person I'm highlighting. Let's submit it. All right. Let's wait for another one. All right. It is almost done. I'll just run the grid once. Okay, let's see. Okay, I think we have to run the whole thing again in order to get that. But anyways, for now we have this particular person being highlighted, and that is working just fine. Maybe we missed this particular part of the image. We'll try just by pointing. Maybe you can try out by yourself. It worked just fine for me when I tried it early, but yeah, anyways, something could have gone wrong. So I'll just run the generated video that we have here. So this is a video that we just created by merging all the frames. All right, so here you see the person. This is working absolutely fine. And I think maybe the bounding boxes were too large for the person one, and it just highlighted the piece of the shoe. So anyways, it's just fine. It depends on the bounding boxes that you have created. You have to be careful, or either you can just tap on the object, so it will also segment accordingly. I hope this works well for you. You can try it out by yourself by using different videos, and I wish you luck. Thanks for watching the video. Please like, share, and subscribe. And I'll see you later, guys. Thank you.